in this example, we are going to solve a right-angled triangle. What does it mean that we're going to solve it? Well, it means that we are going to find all the unknown sides and angles. In this case, where we know that our triangle is right angle, we know that one of the angles is 68 degrees. We need to find the other angle. I'll mark it here and I'll call it alpha. And we know one of the legs of the triangle is 7.5 meters. And then we need to find the other leg. I'll call it A. And we also need to find the hypotenuse. So I'm going to call it B. I'm going to start by finding alpha because that's the easiest. And here we are going to use the fact that the sum of the angles of a triangle is 180 degrees. In this case, we have that 90 degrees plus 68 degrees plus alpha has to be 180 degrees. So then we can find what our angle alpha has to be. We need alpha to be 22 degrees. You can check that this is going to work. So we are done with finding the angles. Now we know the three of them. Now we are going to apply trigonometry to find the sides that we are missing. We can choose which one do we want to find first. Let's say we find A first. And in general, when I solve this type of problems, I will not use the information I already calculated myself before in case I made a mistake and I didn't realize. So I'm going to find A only using the information given at the beginning, so the 68 degrees angle and the leg that has length 7.5 meters. So if I focus on this information, then we have that A is the side that is adjacent to 68 degrees, to the angle of 68 degrees, and then the side that has 7.5 meters of length, that one is in front, so it's the opposite. So I'll write this is opposite to the angle of 68 degrees. So I need a trigonometric ratio that relates a angle, the side opposite to it, and the side adjacent to it. And that's the tangent. By definition, the tangent of the angle at 68 degrees is going to be the same as the ratio between the length of the side opposite to 68 degrees divided by the side adjacent to 68 degrees. In this case, this means 7.5 meters divided by 8 meters, and the A is what we are trying to find. Remember that, well, we do not know by heart what is the tangent of 68 degrees, but our calculator knows it, so that's information we are going to use. So what we need to do now is to isolate the value of A so we can find what it is. And we have, in this case, A in the denominator in the right-hand side. So I'm going to multiply by A both sides so that I cancel the A in the denominator, because I do not want to have an A in the denominator. I want to find A, so I want to isolate it. So I want A equals something. When I multiply by A on the right-hand side, A is multiplying and divided, so it cancels. So this means that A times the tangent of 68 degrees is equals to 7.5. Well, but I don't want A times that number, tangent of 68 degrees, whatever it is. So I'm going to divide both sides by the tangent of 68 degrees. So in the left-hand side, tangent of 68 degrees cancel, and then we get that A is going to be 7.5 divided by the tangent of 68 degrees. And this is what we are going to find in our calculator, what the value is. So find it, stop the video and find it, and we'll check. The result that I'm getting is that to three significant figures, the side A is 3.03 meters. Let's take a second to see if this result makes sense. Well, we know that this is the shortest leg because it's in front of the the smallest angle, the 22 degrees one. So it has to be less than 7.5. So far it looks fine. So I need space, so I'm going to write the result here. A meters is 3.03 meters. And now I'm going to make space to find B, which is the last step we have to do. Now let's go ahead to find B. As I said before, I'm only going to use the information that was given at the beginning of the problem and not the information I found so far, because I want to make sure that I'm not introducing any errors from approximations, and also I'm not spreading any mistake I could have made before. So if I focus on the angle of 68 degrees and then the leg that is 7.5 meters, which is opposite to 68 degrees, then what we have is that, well, actually B is the hypotenuse of this triangle. So I need to apply a trigonometric ratio that relates an angle, the leg opposite to it, and the hypotenuse. So that is the sine. The sine of 68 degrees is equal to the length of the side opposite to 68 divided by the hypotenuse. So let's write that down. The sine of 68 degrees is equal to opposite to 68 degrees divided by hypotenuse. And this, in this case, means that the sine of 68 degrees is equal to 7.5 meters divided by B. And B is what I want to find. We have a situation very similar to the previous one. We have B in the denominator. We want to find B, so we want to isolate B, and we want to have B alone and everything else on the other side. So I'm going to multiply by B both sides of my equation, so it cancels on the right-hand side. So I can say that the sine of 68 degrees is, B times the sine of 68 degrees is equal to 7.5. But I want to find B, so I'm going to divide both sides by the sine of 68 degrees. So it cancels on the left-hand side. We are multiplying and divided by sine of 68 degrees. So what we got so far is that B is equal to 7.5 divided by the sine of 68 degrees. And of course, we don't know what is the sine of 68 degrees, but our calculator does know. So go ahead, stop the video and find this in your calculator. And the result that I get, approximated to three significant figures, is that B is 8.09 meters. And we knew that being the hypotenuse, B had to be more than 7.5 meters. So now we are done solving the triangle because we know the length of the three sides and we know the measure of the three angles. As a little bit extra here, I want you to check that actually the length of the sides that we found are correct, because you're going to check that they verify the equation from Pythagoras theorem, so that 7.5 squared plus here we have an approximation, so we may not get exact values. 3.03 squared has to be equal to approximate 8.09 square. So check this.